This is the Geometry Chapter 6 final review for the Semester 1 final. So we're going to talk about the objectives first. In this chapter we covered finding the sum of the measures of interior angles of a polygon. So we did sum of interior, then we find the measure of just extra. After that we moved on to talk about specific polygons. So we use relationships among sides and angles of parallelograms and then among diagonals of parallelograms. Eventually we moved on to decide if we have a parallelogram or not. Then we actually classified special parallelograms such as rhombuses and rectangles. And we talked about the diagonals of rhombuses and rectangles. We moved on to then talk about trapezoids and kites and their properties. We tossed squares in there with rhombuses and rectangles as well. Then we moved on to the coordinate plane and we classified polygons in the coordinate plane. Then we named coordinates of the special figures by their different properties on our flowcharts. Eventually, we proved theorems using figures in the coordinate plane as well. So we're going to go through a few of these objectives. We're going to start with talking about angles, measures of interior angles and exterior angles and such. So first off, it's just, do you remember what is the formula for the sum of the interior angles and for the measure of one interior angle? So we want our sum and we want one angle. So I want you to try to fill in both those. See what you can come up with. Here's our two formulas we should have. The sum is n minus 2 times 180 and then 1 is n minus 2 times 180 divided by n. So now we're going to use these formulas to come up with some angle measures. It says find the sum of the measures of the interior angles. These are 4 problems. There's 2 where they just explain what the word is, so whether the word is a heptagon or a pentagon, and then the last 2 are actually pictures you're supposed to do. So remember that n in both of our formulas up above refers to the number of sides. And so if we're going to find the sums of these, we're going to use our first formula, n minus 2 times 180. I'll do the first one with you. A heptagon. A heptagon, it's also called a septagon. That's 7 sides. It's one kids often forget. We can plug that in. We go 7 minus 2 times 180. Grab our calculator, type that all in. We get 5 times 180 is 900 degrees. All right, so pause the problem. You got 3 questions left. Try them. Alright, you can check your answers with mine. A pentagon is 5 sides, so I got 5 minus 2 times 180, got 540. The next one, I counted up the sides, it's a nonagon, so I went 9 minus 2 times 180, got 1260. The next one has 6 sides, which is a hexagon. 6 minus 2 times 180 is 720 degrees. So that was our first objective. After that, we moved on to discussing parallelograms. And so this is where it's really important that you know all your properties of parallelograms. So there were properties about sides, there were properties about angles, and properties about diagonals at the end. So it says find the missing measurements in the parallelograms. So in this first one, you can see we have inches on both those measurements, on the 2 and the 5, so those are side lengths. So what we're looking for are the other 2 side lengths. Well, if you're looking at your flowchart from Chapter 6 or your notes packet, you might remember that opposite sides are congruent. So we've got a 5 inches on the top, we're going to have a 5 inches on the bottom. We got 2 inches on the left, we're going to have 2 inches on the right as well. Now if we look at the next picture, you got 35 degrees, that's an angle, which means you need to know the other 3 angles. I'm going to call them 1, 2, and 3 for our purposes. So we need to find all 3 of those. There are 2 properties about angles. Number 1 is about opposite angles, and number 2 is about consecutive angles. So opposite angles we said were congruent, and consecutive angles we said were supplementary. So opposite angles will help me get this angle 2. The measure of angle 2 is going to be 35 degrees then. Now if I want to get the measures of angle 1 and 3, they are going to be the same, but the way I find them is I look at that supplementary relationship across. So I go 180 minus 35, and I should get 145 degrees for both angle 1 and angle 3. So you try the last question on your own then, pause the video, and then check your answers. Alright, you can check my answers with mine. I got 118 on the top right and then 62 on the top left and bottom right. Okay, so that was about our angle measures. Next we're going to go on and we're going to talk about deciding if something is a if a quadrilateral is a parallelogram. So it says, is the quadrilateral a parallelogram with the given information? So we've got 3 images here, or we have to make this decision about it. So I'm going to look at the information that we have in all these images. In the first one, we have congruent marks on the top and the bottom, and parallel on the left and the right. In the second image, we have these diagonals have congruent marks here and here, and there and there. And then on the third one, we got 3 angle measures, 80, 110, and 110. So we had a lot of properties of parallelograms. One of the first ones that we talked about was that opposite sides are parallel and opposite sides are congruent. In this one, they kind of combine those two to say, hey, one pair of opposite sides are congruent and one side are parallel. Well, this picture could truly look like this then, and it would still have all those properties. Opposite sides parallel, opposite sides congruent. However, that's a trapezoid, and a trapezoid is not a parallelogram. So with this information, we actually can't say it. It's a parallelogram. Now, if we had congruent and parallel on the same side, that is enough information. We had a theorem about that. If I move to the second picture, I had those congruent marks I talked about, and you can see that this diagonal is cut in half into equal parts and bisected, and so is the other diagonal. It's also bisected. And we did have a theorem, in fact, about parallelograms that said that their diagonals bisect, so this one will be a yes. If we look at that last one, they're talking angle measures, so what I would look for is some 180 relationships. So if I've got 80 and 110 right here, I look at what those two add up to, and that's 190 degrees. Now, if this is a parallelogram, those two should make 180 degrees, and since they don't, this is going to be a no. And I don't even necessarily even have to go get that fourth angle or look at the other 110. I found a consecutive relationship that isn't 180 degrees. So after that, we just tried to classify special types of parallelograms. We discussed quadrilaterals, parallelograms, rectangles, rhombi, and squares. So I'm going to leave you with these 4 pictures for a moment and see if you can decide, okay, with the information I have, knowing that all these shapes are parallelograms, they do give you that, can you come up with a more specific name or not? So pause the video and try it. Alright, so what I just did in green is I went through and added extra markings to these pictures that I can add because I know they're parallelograms, and they go with the 5 properties. So for this first one, I was able to add congruent marks on the other 2 sides because opposite sides are congruent. I was able to add the green angle markers because opposite angles are congruent and consecutive are supplementary, which gives me 4 right angles and 4 congruent sides, which tells me that this shape, the best name I can give it, is square. I go to the next one. I was able to add markings like this with the sides, to say the top and the bottom are the same and the left and the right, because opposite sides on a parallelogram are congruent. Then I was able to add in this angle marker because of the supplementary relationship, and the other 2 I was able to add for their congruent opposite relationships, which leaves me with 4 right angles and 2 pairs of congruent sides. This is a rectangle. I'm going to look right below it. I was able to add markers on this one because opposite sides are congruent. Gives me 4 congruent sides. I can't say anything about the angles, so the best name I can say is that this one's in fact a rhombus. And last but not least, this is the one that most people get wrong. Oops. A lot of people want to say that this is a rectangle right off the bat. However, we can't say anything about those angles. All we know is that the opposite sides are congruent in a parallelogram, so actually the best name for this one is parallelogram. If you knew something about the angles, you might be able to say more, but with our information, we can't. So we ended the chapter talking in the coordinate plane a little bit. Right before that, we got into trapezoids and kites, and so that's where we're going to go next. It says, find the missing angle measures. And so we've got 2 problems here. We have a kite on the left and a trapezoid on the right. Now, if I remember correctly, we had 4 different properties of of kites on our flowcharts we discussed. One of them being that in a kite, you have 2 pairs of congruent sides. You've got stuff about the diagonals and such, and one of the big ones about the diagonals is that they're perpendicular. So it allows me to put a right angle mark in there. Now, what I'm looking for are angle 1 and angle 2. And if I look, I can make this really nice triangle here and here. And if you notice, those triangles look the same, and actually They are, because that long diagonal bisects congruent angles. And so I can say, well, if this is 18 down here, and I've got a 90 up there, I can go 90 plus 18, get 108. I can subtract that from 180 to go get angle 1, and I should get 72 degrees. Now, if I want to think about angle 2, you can kind of see that these triangles are mirrors of each other. So if you reflect along this line, they're congruent. Angle 2 lines up. Angle 2 is also going to be 72 degrees. So I move over to my trapezoid. I need to get measures of angle 1, 2, and 3. I'm going to have you pause it for a moment and see how many you can get without any help. You should have gotten that angle 1 is 109 degrees. This is an isosceles trapezoid, so those base angles are congruent. Then you have a supplementary relationship here, which should get you angle 3 to be 71, which you can then use to say that angle 2 is also 71 degrees. Okay, we have been a little light on the algebra so far, so we're going to go dive into a few problems that have algebra in them. What we're supposed to do is we're supposed to solve for the variables. So on this first one, we're given AC and BD. You can see that this is AC and this is BD. Now, I'm going to make an assumption this is probably a trapezoid from these congruent marks on AD and BC. And if it is an isosceles trapezoid, that this one's going to have congruent diagonals, which allows me to say, hey, well, that x plus 5 is equal to that 2x minus 2 and solve. So we're just going to quickly solve. And we should get x is 7. And that's really all they wanted us to do. Sometimes they ask you to plug stuff back in, sometimes they don't. Now, this next question, these next two are probably the hardest two up here. I'm going to need some more space on this one. So let me slide that down. We have a trapezoid up top, and if you notice, what we have are a base, and then this is a mid-segment. Now, we had a formula that said that the mid-segment equals 1/2 base 1 plus base 2. So that's what we're going to do. We're going to set up that equation. So I go and I start by finding the mid-segment. That's this one here in the middle. That's 4x plus 1. So it's going to equal 1/2 of the bases. Well, the top base is 10, and the bottom base is 6x minus 2. And now I have this lovely equation that I'm going to take the time to solve. I'm actually going to make you guys try to solve it and check it. So pause the video, try to solve it, and then check your answer with mine. Alright, you can see my answer, what I did. I started by distributing that 1/2 through, then I got 4 plus 3x in the place, did some moving around, and I got x to be equal to 3 in the end. Alright, lastly, we're going to look at this shape down here. If you take a look at it, you want to think about what is it? Well, it's a kite. And we have a few variables to find on this one. I notice an x, and I notice a y. So we got to find both of those. Now the key to kites is making triangles. And so if I look on the left, I've got one angle on that left triangle, but on this right triangle, I have 3 angles. And if I notice I've got a 38, something with an x, and something with an x. Well, I can solve that by saying all the angles in a triangle add up to 180 degrees. So I set up my first equation. I've got 38 plus 17x plus 1 plus 3x plus 1 is 180. And I start to simplify. So I've got 38, 39, 40 plus 17 plus 3 is 20x equals 180. I keep going, subtract 40 from both sides. 20x equals 140. I divide, and x is 7, which is pretty straightforward. Now, we had a question similar to this on our homework this year, and I remember that we struggled with getting our y variable next. So in a kite, there's a few things you need to remember. The long diagonal bisects the angles it goes through, and the short diagonal connects congruent angles. So that means that this 2y over here is going to be the same as that 17x plus 1. Now we could figure out how much 17x plus 1 is because we know x is 7. So I'm going to quick plug that in, see what I got. So I've got 17 times 7 plus 1. And that gets me 120 degrees for that angle. Well, this is a 2y angle, so 2y then equals 120. Now I just keep solving by dividing by 2, and y is in fact 60. So x was 7, and y was 60. All right, so this was your geometry chapter 6 review for the final. I hope you learned something here.